How and when did our universe begin? How did it get to look like this? How will it end? Humans have been discussing these questions for as long as they've been around, without ever reaching much agreement. Today, cosmologists are working hard to find the answers. But how can anyone hope to find concrete answers to such profound questions? And how is it possible to explore and study something as huge as the universe, most of which we'll never be able to reach? The answer is light. And although light from distant parts of the universe can take billions of years to reach us, it carries 6 unique messages that, when put together, can disclose an amazing amount of information to astronomers who know how to look for it. Just as sunlight can be split up into the familiar rainbow, splitting the light from distant objects exposes different patterns of colors depending on its source. This distinctive light barcode can reveal not only an object's composition, but also the temperature and pressure of its constituent parts. There's even more we can discover from light. If you've ever stood on a train platform, you might have noticed that the train sounds different depending on its direction, with the pitch ascending when it approaches you and descending when it speeds away. But this isn't because the train conductor is practicing for a second career. Rather, it's because of something called the Doppler effect, where sound waves generated by an approaching object are compressed, while those from a receding object are stretched. But what has this to do with astronomy? Sound does not travel through a vacuum. In space, no one can hear you scream. But the same Doppler effect applies to light whose source is moving at exceptional speed. If it's moving towards us, the shorter wavelength will make the light appear to be bluer, while light from a source that's moving away will have a longer wavelength, shifting towards red. So by analyzing the color pattern and the Doppler shift of the light from any object observed with a telescope, we can learn what it's made of, how hot it is, and how much pressure it's under, as well as whether it's moving, in what direction, and how fast. And these 6 measurements, like 6 points of light, reveal the history of the universe. The first person to study the light from distant galaxies was Edwin Hubble, and the light he observed was redshifted. The distant galaxies were all moving away from us, and the further away they were, the faster they were receding. Hubble had discovered our universe is expanding, providing the first evidence for the Big Bang theory. Along with the idea that the visible universe has been constantly expanding from a densely packed single point, one of this theory's most important predictions is that the early universe consisted of just 2 gases, hydrogen and helium, in a ratio of 3:1. And this prediction can also be tested with light. If we observe the light from a remote, quiet region of the universe and split it, we do indeed find the signatures of the 2 gases in just those proportions, another triumph for the Big Bang. However, many puzzles remain. Although we know the visible universe is expanding, gravity should be applying the brakes. But recent measurements of light from distant dying stars show us that they're farther away than predicted, so the expansion of the universe is actually accelerating. Something appears to be pushing it, and many scientists believe that something is dark energy, making up over 2/3 of the universe and slowly tearing it apart. Our knowledge of the behavior of matter and the precision of our instruments means that simply observing distant stars can tell us more about the universe than we ever thought possible. But there are other mysteries, like the nature of dark energy, upon which we have yet to shed light.